What's going on, Algebra Bros? Mr. C here, and in this video, we're going to solve problem 5 of Mr. C's My Math Lab Practice Unit 1 exam. So number 5's got a couple of parts. Let's see what's going on in this one. A ball is thrown vertically upward from the top of a building 112 feet tall with an initial velocity of 96 feet per second. The distance s in feet of the ball from the ground after t seconds is s equals 112 plus 96t minus 16t squared. So there's a couple ways to do this, each part that is. We could use algebra, okay, a by hand method using the quadratic formula, but I'd like to show you how to solve this using the graphing calculator. But I would like to draw a little diagram first. So let's imagine this is our ground. And we have our building. And this building is 112 feet tall. And something is throwing the ball upward from the top of the building. And let's say it's right here. And it's going to go up, and then gravity's going to take over and bring it on down to where it hits the ground, maybe creating a Michigan pothole, right? And when there's enough rain, it becomes a swimming pool, right? But anyhow, what you could do to solve this using a graphing calculator is type this equation into the y equals menu, treating s as y1 and t as our variable x. Now let's go to the graphing calculator. And in y equals, we'll clear out that stuff. Let's type in 112 plus 96x minus 16x squared. Now if we hit zoom 6, we're probably not going to get anything that's very helpful. Well, at least not the whole picture. So we're going to do some window setting adjustments, and we'll do a couple of things to help us with the settings. So let's hit the window button, and keep in mind the x values represent time, and time is never negative. So at a very minimum, let's have time be 0, representing 0 seconds. Now for the maximum x value, I'm going to go to the table feature by pressing second graph, and you'll notice that with each of these x values, the y values are positive. I'm going to scroll down in the table until the y values become negative, and they start becoming negative after x equals 8. Now this is going to be helpful when defining x max, because let's assume that the ball doesn't go into the ground, meaning that the height will never be negative, so there will be no negative y values or negative s values. So I'm going to go back to window, and I'm going to choose x max as 8, and we can use 1 for the scaling, okay, not a terrible amount of tick marks going from 0 to 8 on the x-axis. Now again, let's assume that the ball doesn't go into the ground, and so the minimum height would be 0. But as you'll see, we're going to use the 0 feature, so I'm going to want a little bit of the graph underneath the x-axis to help accommodate the right bound. So I'm going to put the y min, let's say at -5, and then I'm going to go back to my table, and between 0 and 8, I want to look for the largest y value on the right. So we start at 112, which is the height of the building. We go up to 192, then 240, then 256, then back down to 240, and we go all the way down until we get to 0 at x equals 7, and then of course a negative height at x equals 8. So the largest of the y values here is 256. Now I'm going to overshoot that a little bit and define y max as 260. And we can go by 5s or 10s or even 20s, whichever you prefer. I'm going to go by 10s and see what the graph gives us by pressing graph now. And so that's pretty much the path of the ball after it's thrown up from the building with the initial velocity and initial height. So I'm going to sketch that out. Well, we already have the path, right? Now let's assume that this is we can superimpose or resketch this using an x and y axis or a t and s axis. And our graph did something like this. Now keep in mind the maximum t value on our graphing calculator was 8. We set y min at -5. X min was 0. And then, X min and Y min were 0, and then Y max was 260. So there's our setup. Let's look at part A. It says, after how many seconds does the ball strike the ground? So clearly this is where the ball is going to strike the ground, and that would be an x-intercept of our graph. So we can use the 0 feature to help us figure out the specific value of t for which this happens. So I'm going to go back to the graphing calculator, and I'm going to press second trace. We'll select option 2, and we actually saw a sneak peek of the time value for which the height is 0 in our table. And actually, I think I'm going to change my window to go a little bit lower on the y-axis, just so that things aren't being too terribly covered up. Maybe I'll go to -20. Okay, let's see what that does. So second trace, option 2. Alright, that's, I guess, a little better. So for a left bound, somewhere about right here would be a good spot for your left bound. Go ahead and press enter. And then for your right bound, we'll just kind of have to imagine us going a little bit under the x-axis. We're kind of covered up by the y coordinates there. And just to keep track of where my blinking cursor is, I'd say right here is probably good enough for your guess. As long as you're close to the x-intercept, your calculator can kind of figure it out from there. Go ahead and press enter, and voila! It looks like when t is 7, or in other words 7 seconds, that's when the ball is going to hit the ground. Alright, and we actually saw that in our table, but I wanted to show you the 0 feature way instead of the table, because oftentimes the answer is not in the table, just based on how x is being incremented. So going back to the diagram, the point at which the ball hits the ground with respect to the coordinate plane would be at 7, 0. In other words, it takes 7 seconds in order for the ball to hit the ground. Now for part B, it says, after how many seconds will the ball pass the top of the building on its way down? Well, there is a point for which that happens. If we imagine drawing a line from the top of the building to the trajectory, this is the point that they're referring to in question part B. Now in terms of a graph, we're going to define a second equation, y2, and y2 is going to be a horizontal line that crosses the y-axis at 112, because that's the height of the building. So y2 is going to be equal to 112, and let's go ahead and type that into the y equals menu. Press y equals, go down to y2, type in 112, press graph. And we're going to go ahead and find the second point of intersection. We'll press second trace, option 5. We'll scooch the blinking cursor over to this point of intersection, and we'll press enter 3 times. And it looks like after 6 seconds, that's when the ball will, pass the top of the building on its way down. So our final answer for part B is going to be t equals 6 seconds. Alright, well, I hope you had a ball with this video. Of course, if you have any questions from it, feel free to let me know. Otherwise, thank you for watching, and I will see you guys soon. Take care.